All right, so let's look at the lesson 9 problem set from module 1. So this lesson's all about being able to write equations that represent entire proportional relationships. And then since proportional relationships always have two quantities that are varying together, you should be able to apply the equation to find one quantity if a question gives you the other quantity. If the question number 1 here is about how much you weigh on Earth versus how much you weigh on the moon, well, we can make an equation that represents that. And then if they tell us something about how much you weigh on the moon, we should be able to figure out how much you weigh on Earth. Or if they tell you something about how much you weigh on Earth, using our equation, we can figure out how much you must have weighed on the moon, and vice versa. And that's sort of what it's all about. And so these equations always look like y equals kx. That's what we call the general form. And then all we do is we figure out a k, an actual number k. Oops, I'm not even on the screen. So that's what I was writing. We find an actual k, a number that goes with the relationship, and we just substitute it right here instead of this letter k, and then we work from there. You'll see how it goes. Let's do a few of them. All right, so number 1, I'm going to do all my work on a separate piece of paper because look at this ridiculous amount of questions they want you to do for number 2 and like no space that they give you to do any of it. So I recommend using another piece of paper. It says a person who weighs 100 pounds on Earth weighs 16.6 pounds on the moon. That's because the moon is smaller, and so it has less gravitational pull, which means you weigh less there. So which variable is the independent variable? I hate the fact that they asked us this way. So what they're really asking you here is which one are you going to treat as x? So which is x and which is y? Oops, I was going to write the word y instead of the letter y. Whichever one you decide to treat as x, we call that our independent variable. Independent. I had to actually look over here to see how to spell it. I was going to put an A in there somewhere. And then this one, y, is called the dependent. And essentially, there's lots of different ways you could think of this, or lots of different ways that teachers try to explain what this means to students, but the independent variable means it does not depend on the other thing. Usually, when you have two quantities that are changing together, one of them changes because the other one changed. So in other words, one of them depends on the other one to happen first. Usually time is always considered independent because time doesn't depend on anything else. If you're looking at time and the number of cookies you can bake in that amount of time, well, the amount of cookies you can bake depends on how much time you have. Time doesn't go faster or slower or depend in any way on how many cookies you baked. That would be silly. And so when they ask me which is the independent variable on this one, they're asking, does how much you weigh on the Earth depend on how much you weigh on the moon, or does how much you weigh on the moon depend on how much you weigh on Earth? And that's a really weird question. The default I would go back to is which thing do we always know first? I've known for a long time how much I weigh on Earth, and I can find that out really easy anytime I want. I would probably have to do some math in order to figure out what I weigh on the moon, because it'd be really hard for me to actually go there and weigh myself. So I would say that how much I weigh on the moon depends on how much I weigh on Earth, because I know how much I weigh on Earth first, and I would have to do some math to figure out what I weigh on the moon. That's probably really confusing. The bottom line you need to know is that we're going to make x our Earth weight, and we're going to make the moon our y. So for 1a, I would just say that Earth is probably really tilted. Earth weight is independent. I always feel like there should be an A in that word, or X, because we know it before we know our moon weight. All right, so what is an equation that relates weight on Earth to weight on Moon? So we need this equation. And remember, there's 2 steps to finding this equation. Don't write the next part that I'm going to write if you're kind of following along with me. Step 1, in fact, I'll write it over here. To get the equation, step 1 is find K. Step 2, write the general form of the equation. General form. Remember, that's up here. Oops. Right there. Except put your K instead of the letter K. Right? Whatever number you found. So, step 1, find K. So we're treating, K is always y divided by x. And we're treating our Earth weight as x. And according to the problem, there's a person who weighs 100 pounds on Earth. So I'm going to put 100 where the x was. And 16.6 on the moon, that's y. And so I have to do 16.6 divided by 100. That's actually really easy because when you divide something by 100, you just wind up moving this decimal point over 2 spaces. And so our K is going to be 0.166. And now step 2 is just write the general form of the equation, y equals kx. Exactly the way you see it there, except you're going to replace the K with your 0.166. Right? It's literally exactly the same, except I wrote 0.166 instead of the letter K. And there's our equation of this relationship. So you can find any moon weight, y, equals 0.166 times your Earth weight, y. Or sorry, x. I said y, I meant x. So how much would a 185-pound astronaut weigh on the moon? So we have our equation here. I always like to start by just writing my equation. I did a lot of work to get it. I might as well use it. And then the question is giving us a piece of information. This person weighs 185 pounds on Earth. It says how much would a 185-pound astronaut weigh on the moon? They mean this person weighs 185 on Earth. And so we're going to figure out how much they would weigh on the moon. Well, Earth weight is an x value, right? We decided that Earth would be x. So that means this number needs to get substituted for that x right there. And so we write our equation again. Y is going to equal 0.166 times 185. And you'll get your answer. I'm not going to plug it into a calculator or figure it out for you. You figure it out. And then D, it says, how much would a man who weighs 50 pounds on the moon weigh on Earth? So this time they've given us a moon weight. I'm going to start just by writing my equation and then writing the information I was given. 50 on the moon. And so since this is a moon weight and moon is y in our equation, I'm going to substitute this 50 for the y there. And so I'll rewrite the equation as 50 equals 0.166x. Remember, these are the harder ones. Because in the previous one, you just had y equals, and then you do 0.166 times 185. This one's not so clear, because it says 50 equals 0.166 times some variable. How are we supposed to figure out what that variable is? Well, the trick all comes down to understanding that multiplication and division work in opposite of each other, or they are inverse operations, as the way a math teacher would say it. So what that means is that I'm going to show you like a separate example so you can see what I'm doing here. Let's say you had the equation 8 equals 4 times blank. And you wanted to figure out what goes in that blank. I bet you can already see that 2 goes in that blank. But what if you couldn't figure that out? Well, you could work backwards and say, well, wait, if this times this equals 8, then that means 8 divided by that 4 must equal what goes in that blank, which is the 2, right? We're just using the fact that division sort of undoes multiplication. And so let's do the same thing here. Just like I had 8 equals 4 times blank, and I reversed it to go, that means 8 divided by 4 must equal blank. If I have 50 equals 0.166 times blank, that means that 50 divided by 0.166 must equal, I'm not going to say blank, I'm going to say x. When you do this division, you might be surprised that you get a number way bigger than 50 pounds. When you divide by smaller decimals, like 0.166, or any number smaller than 1 and bigger than 0, the quotient, the number you get after you complete the division, is actually bigger than the number you started with. And lots of people find that very surprising. Let's move on to number 2. I'll go to another piece of paper. So it starts off with that same question: which of these quantities should be the dependent variable? And so we have this table with gallons of gas and number of miles driven. And see, I hate this question because they're asking us which one depends on the other. Does the number of gallons of gas you use depend on how many miles you drive? Or does how many miles you can drive depend on how much gas you have in the tank? I don't really know if you can answer that correctly, given, like, there's not enough context in this table. It just says gas and miles, basically. And so honestly, I don't really think there's a good, correct answer to 2A. I think really you should just pick which of these quantities you want to treat as X and which one you want to treat as Y. And I don't really have a great reason for either way. I just think I'm going to treat the left side of the column as X and the right side as Y, and let gallons be X and miles be Y. And so that's all I'm going to write for number A. I'm going to just say gallons is X, which I guess that makes it our independent variable. So how much gas you have in the tank is independent, and then miles will be Y. And so I guess what we're saying is, or what I'm saying, is that the number of miles you can drive depends on how much gas you have in the tank. And so B says, is the number of miles driven proportionally related to the number of gallons of gas consumed? So essentially they want you to check if this is proportional. You could do that with a table in here, like this. Call this your Y divided by X column. Normally we put it on this side, but I have words over here. Y divided by X. And then just check 62 divided by 2, 124 divided by 4, 31 divided by 10. I'm pretty sure it comes out proportional because otherwise they wouldn't be asking you the rest of these questions. But go ahead and find the K doing that. I guess I need the K if I'm going to keep helping you, so I guess I'll find it. 62 divided by 2 is 31. We don't worry about the 0 divided by 0. It just is what it is. 124 divided by 4, that's also 31. 310 divided by 10, that's 31. So, yes, it's proportional. And the K equals 31. So, it hasn't asked us to do it yet, but I like to get in the habit of, as soon as I know what the K is, I might as well write my equation. Because all you have to do is write that general form, y equals kx, but you just put the 31 where the K goes, y equals 31x. So I've already got the equation for this relationship in case I need it later. C. Is any ratio relating the number of gallons of gas and the number of miles driven, in any ratio relating the number of gallons of gas and the number of miles driven, will one of the values always be larger? You know what? I'm going to let you think about that one and answer it yourself. That's an interesting question, and I feel like you could probably figure it out without me. If the number of gallons of gas is known, so I'm reading D now, can you find the number of miles driven? Explain how this value would be calculated. So they're saying if you knew the gas, which is X for us. So we have this equation, y equals 31x. And yes, if I knew the gallons, which would be X, right? This X, then I would multiply by 31 to get the miles. E says if the number of miles driven is known, can you find the number of gallons of gas consumed? So let's write our equation again. It's y equals 31x. Remember that y stands for the number of miles and x stands for the gallons of gas. And they're asking you if you knew y or the miles, could you figure out, x? Yes. That's the whole point of this. If I give you one thing, you should be able to find the other. If I knew the miles, then I would, now remember, this way when you're given an x value, you just multiply by the k, 31 times x. This is, when you're given a y value, the miles is a y value, you have to divide in order to figure out what x is. I would divide by 31 to get the gallons. And so the next four parts, F, G, H, and I, ask you to do exactly that. They're going to give you either an X value for gallons or a Y value for miles and ask you to find the other. I'm going to do one and then probably leave the other three for you to do. So it says, F says, how many miles could be driven with 18 gallons of gas? And so I'm going to start by writing my equation. Again, y equals 31x. And I'm going to write down here that they gave me 18 gallons. And that's an x value, right? Gallons is x in the way we have this set up. So I'm going to substitute 18 for x. So I get y equals 31 times 18, which equals, I'm going to let you, punch that into a calculator or do it by hand, however you're going to do it. Wait, let me do the other one, because G is the opposite. G says, how many gallons are used when the car has driven 18 miles? So it's a number 18 again, but this time it's miles. So I'm going to write my equation one more time, and I'm going to write 18 miles was the info I was given. And this time, since it's miles, I'm substituting in for y. And so the equation becomes 18 equals 31x. And I have to remember, if x times 31 equals 18, then I can work backwards and go 18 divided by 31 equals x. And 18 divided by 31 should be less than 1. It's going to be somewhere around a half, which makes sense because they can go 31 miles on every gallon, and they're only going 18 miles. So it should be like half a gallon, 0.6 of a gallon, something like that. All right. I think I'll at least do parts of number 3 with you, or maybe I'll do number 3 and leave number 4 on the backside for you, because this video is getting kind of long. We're almost at 20 minutes now. So it says, suppose the cost of renting a snowmobile is $37.50 for 5 hours. If C represents the cost and H represents the hours, good. They still want to ask us the stupid dependent stuff. Okay, so which variable is the dependent variable? Why? So does the amount of time that you get to keep the snowmobile depend on how much you pay? Or does how much you pay depend on how much you want to keep, for how long you want to keep the snowmobile? I think you could make an argument for either way. That's why I really hate these questions. I guess I would probably go with the cost you pay is dependent on how long you want to keep the snowmobile for. So I guess that's how I would answer this question. So I would say that C, the cost, is dependent on H because you pay depending on how long, let me get some of this other stuff out of the way so you don't see that, how long you rent it for. So if C is the dependent variable, then that makes C essentially like Y, right? So I'm going to write a little Y over it. Y is always the dependent variable, and X is always the independent variable. And so, you know what, actually I guess this one is a little bit easier, because like I was saying in class, from a scientist's perspective, if you have a unit of time, hours, seconds, years, days, whatever, that's always your independent variable. Time doesn't depend on anything else. So keeping that in mind, I guess this probably is the right way to do this. And so B says, what would be the cost of renting 2 snowmobiles for 5 hours? Well, renting 1 snowmobile for 5 hours costs $37.50. So 1 snowmobile. So I don't think we're going to need an equation on this one. I think this one they're just trying to check if we can figure this out. 1 snowmobile for 5 hours costs $37.50. So 2 snowmobiles, snowmobiles for 5 hours each, right, should just cost double that. I mean, you're not changing the amount of time you're getting them for, you're just renting 2 of them. So it should be just 2 times the price. So I'm gonna let you fill in the blank. It should just be double. All right, so this video is getting pretty long. I feel like I should leave something for you to try without my help, so you do number 4.